Have you ever looked up at the night sky and wondered what's really up there? It's not just stars and planets anymore. Above our heads, invisible highways are forming, packed with thousands of satellites. These megaconstellations are a technological marvel, promising to bring high-speed internet to every corner of the globe. Companies like SpaceX, with its Starlink project, are leading this charge, launching satellites at an incredible pace. But this new space race, happening right in our own backyard, comes with a hidden cost and a growing risk. What is this risk? Space debris, low Earth orbit, or LEO, is becoming dangerously crowded. Imagine a highway with no traffic rules, where cars are speeding at thousands of miles per hour. That's what LEO is starting to look like. Every satellite launched is a potential piece of space junk. If one satellite fails or collides with another, it can create a cloud of thousands of tiny, fast-moving fragments. Each of these fragments becomes a projectile, capable of damaging or destroying other satellites, creating a chain reaction that could make entire orbital paths unusable. This scenario, known as the Kessler syndrome, isn't just science fiction anymore. It's a real and present danger that threatens our entire space infrastructure. The astronomical community was among the first to sound the alarm. These bright, reflective satellites streak across the night sky, photobombing sensitive telescopic images. For astronomers trying to study distant galaxies or detect potentially hazardous asteroids. These satellite trails are like trying to read a book while someone shines a flashlight in your eyes. It obstructs their view of the universe and compromises crucial scientific research. Beyond astronomy, space agencies like NASA and the European Space Agency are also deeply concerned. They operate vital scientific instruments, like the Hubble Space Telescope and the International Space Station, which are now at an increased risk of collision. The ISS has already had to perform avoidance maneuvers to dodge debris. The more crowded space gets, the more frequent and risky these maneuvers will become. This is why SpaceX recently made a pivotal decision to lower the orbits of thousands of its Starlink satellites. Originally planned for higher altitudes, they will now operate much closer to Earth. So, why does this matter? It's all about orbital decay. At lower altitudes, there's still a tiny amount of atmospheric drag. This drag acts as a natural braking system. When a satellite at this lower altitude fails or reaches the end of its life, the atmospheric drag will gradually slow it down, causing it to fall back to Earth and burn up in the atmosphere within a few years, instead of decades or even centuries. This self-cleaning mechanism is a game changer. It means failed satellites won't linger in orbit as long-term threats. It's a proactive measure to prevent the buildup of space junk. This decision to lower the satellites wasn't just a simple engineering tweak. It was a direct response to the mounting pressure from astronomers, regulators, and the entire space community. It shows a growing awareness that launching thousands of satellites comes with a profound responsibility. It's not enough to just put them up there. You have to have a plan for bringing them down safely. This move sets a new precedent for responsible space operations. It sends a clear message to other companies planning their own megaconstellations. You must factor in the entire life cycle of your satellites, from launch to orbit. Space is a shared resource, and we all have a stake in keeping it safe and accessible for future generations. The choices we make today will determine whether the final frontier becomes a gateway to the stars or a cosmic junkyard. Thank you so much for watching. What are your thoughts on the future of low Earth orbit? Let me know in the comments below. Do not forget to subscribe to the Cosmic Drive and hit that like button to fuel your mind beyond limits. We'll see you in the next video.